Okay, we are not going to have a lab tomorrow because we are behind what we should be because the other groups were struggling a little bit with the math of the speed of light stuff. So we're going to go over that today, and then we're going to do another round of problems of speed of light. Guys, the only thing I can tell you though is this. If you're not getting this, if you do not understand how to do metric conversions, if you do not know how to rearrange a formula to, get what you're looking for, if you don't know how to put things in your calculator, you have got to see me. Sitting there in silence and thinking that it's going to go away is not going to happen. You will see metric conversions for the rest of the semester. You will see speed of light problems and other type of calculations the rest of the semester. Please come see me. Ask questions during class. I guarantee you, you ask a question, there's probably 4 other people here going, thank goodness they asked that question. Questions are not a sign of being dumb or not understanding. It's a sign of wanting clarity. So ask questions, okay? So I need to make sure you know this stuff. That's the only reason I'm slowing down, okay? So let's look at that paper, and let's go over the first few answers. So it says the speed of light is, what is the speed of light? Yes, Tim?
3 times 10 to the 8th.
Good job. All waves can be described in terms of their amplitude, wavelength, and what, Sam?
Frequency.
Good. Early in the 20th century, scientists found that light has the characteristics of both what and waves. Savannah? Headaches? I'm sorry? Particles and waves. Wonderful. The watt of a wave is the number of complete waves passing a fixed point in a given time. What do you think about that, Lexi?
I put peak.
Okay, I don't think it's peak. It's, what do you think?
Frequency.
It's frequency. When something passes something every so often, it's frequency. When the boys are, it's too cold and they're running in the hallway for their conditioning, I know how frequently they come past me, okay? And then I'm usually waiting outside with my air gun to come around the corner and scare them. It's very much fun, okay? I did that one time, though, down at the end of the hallway, and I did not know a kid went to Wendy's and was carrying a bag of food and 4 large Cokes, and as he came around the hallway, I jumped out and scared him, and that everything went up in the air. I was like, oh! It came down and went everywhere. I was diving for the sodas trying to capture. I knew what was happening. I'm like, no! But the team was right behind him. So I was waiting for the team, and I heard him come around. I went, pew! And he went, so it was, I don't do it down that end of the hallway anymore. So when you run, I'll get you up here. But it's frequency. I knew how often they were coming around, so I was ready for them. Just not ready for him. The color of visible light that has the longest wavelength is what? What do you think over there, Cole?
Red.
Red. A wave with a high frequency has what kind of wavelength, Tim?
Shorter.
Shorter. Good. What's number 7? Wavelength. Number 8 is crest. See you all mouthing it, but no one to say it. Number 9 is amplitude, and 10 is trough. Good. And which drawing indicates a shorter wavelength, A or B? A. Now, this next part befuddled some people. But guys, what I ask you to do is Google it. You can Google anything. You all have a wealth of information at your fingertips. A wealth. Things that I can never imagine. And I Google all kinds of stuff. If I don't know what I'm talking about, or if I don't know how to do something, or if I'm just curious, I Google it. Now, I'm not always saying the websites I go to are probably true, but I Google a few things to see how to do it. But I watch videos a lot. I replaced my phone screen a couple years ago, $10. I Googled how to do it, what I needed, I ordered it, took my heat gun, took off the glass, put the new one in, brand new, $10. I was not going to pay $100 and something to have my screen fixed. So I figured out how to do it myself via Google. If I can do that, you guys can look things up as well. Okay? So there should never be an excuse, I didn't know. I can take I don't understand. But saying I don't know and I can't figure out how to get an answer in this day and age should never happen. Right? There's an answer for everything out there, always. Okay, so the waves from long wavelength and low frequency starts with radio waves, then microwaves or radar, infrared. Then, of course, your visible spectrum is Roy G. Biv. Remember that from middle school? Red, orange, yellow, green, blue, indigo, violet. After violet, obviously, comes ultraviolet, X-rays, and gamma radiation. Yes, sir.
Did you have to put it in that order as long as you had them in the right section?
Yes, you have to put them in that order. Yes, because they actually change wavelengths. So gamma has the shortest wavelength and the highest frequency. UV has a little bit lower. And then now for these problems. Let's try this. Okay, good. Let me see, I'm here what I'm doing. Yay. Okay. So some of you had some issues with this and some of you didn't. So I'm just going to treat everyone like we didn't know we were talking about it first. Just so we can see where we are. One thing I strongly suggest until you get all this down, you give yourself sections. 1, 2, 3, and 4. Here are my givens. Here's my equation, my substitution, my answer, and my unit. GSAL. Okay? So the first one. Ozone protects the Earth's inhabitants from the harmful effects of UV light arriving from the sun. This shielding is a maximum for UV light having a wavelength of 295 nanometers. So 295 nanometers is our wavelength. What is the frequency? So I want to know frequency in hertz. Well, the first thing I need to do, see how it's nanometers? I have to get that to meters. I must. Meters is the unit we want for wavelength. So one thing you have to know is that wavelength is measured in meters. Frequency is measured in hertz, S minus 1, or 1 over S. All three of these are the unit for hertz, or for frequency, sorry. So I need to get it to meters. And give me a second. I should do that, but my overhead. So. Okay, so I need 295 nanometers. I multiply it by the equivalent factor. Nanometers goes at the bottom. What I'm looking for, meters goes at the top, correct? What's larger, meters or nanometers? Meters gets the 1, nano gets the 10, and it's 10 to the 9. Okay, there are 9 spaces between meters and nanometers, but the answer is 2.95 times 10 to the negative 7 meters.
I was just looking at the wrong problem, actually.
Oh, okay, okay. So this is what I'm going to use for my wavelength. So my equation is going to be C equals lambda V. I have to rearrange it to get V by itself. So I'm going to divide both sides by lambda. So C over lambda equals V, which is frequency, right? Now I substitute my numbers in. 3 times 10 to the 8 divided by 2.95 times 10 to the negative 7. And my answer should be 1.02 times 10 to the 15th, and of course is hertz. How did you guys do with that? Got it? Good. Any questions on this one at all? I see people writing, so talk to me. Is there something we just need to go over? I don't want to find this out on the quiz. Okay? Tomorrow we'll have a quiz probably over these and atomic structure. Yes, ma'am?
Do you want us to include the units in the work I can do? Or just-
You do not have to. As long as you know what the units are, that's fine.
What's
Yes.
like the S minus 1?
S minus 1 is the unit for frequency. It's per second.
Okay.
So it's per second. So far, so good? Okay, let's look at the next one. Whoops. Let me grab up. Look. Turn this thing off. Thought it was off. Turn it back on for lunch. Okay. So, let's see this.
Good. Are we allowed to use this prefix sheet?
Not on the test, no, but you can use it now. That'd be fine. Yeah, on the test, the prefix sheet's on the back, and this that little line on the back of your periodic table.
So do we have to memorize this?
No. If basically I took that and made it this big on the back of your periodic table.
We're allowed to use that.
Yeah, you'll always be allowed to use a periodic table, except for your element test. It's the only time I don't let you use the periodic table. Okay, so radar signals are also a part of the electromagnetic spectrum in the microwave region. A typical radar signal has a wavelength of 3.19 centimeters. What is the frequency? I have to get my centimeters to meters, right? It has to be in meters. So I say centimeters on the bottom, meters at the top. What's larger? Meters. How many spaces between meters and centimeters? Two. So my answer is going to be 0.0319. Okay? And I'm not going to round it just yet because I round my answers, not necessarily my conversions. Okay? But you can round it if you wanted to. So then I do C equals lambda V. C over lambda equals V, correct? So then I say 3 times 10 to the 8th divided by 0.0319. And that should give me 9.40 times 10 to the 9th hertz, or S minus 1, or 1 over S. Yes, sir?
Why is it hertz and not meters?
Because we're looking at for frequency. Frequency is measured in hertz.
So it just changes? Is it with meters?
Well, no. Okay. Think about what we're saying. The question is, a typical radar signal has a wavelength of 3.19 times 10, or 3.19 centimeters. That's this wavelength. Okay? I want to know how many times it goes up and down per second. That's frequency. So frequency is measured in hertz. Just like if I said, okay, how far away from the school do you live distance-wise? What would you tell me, approximately?
I don't know.
Okay, so let's say you live 12 miles away from school. You wouldn't say, and I said, okay, well then tell me how long it takes you to get here. You wouldn't say it takes me 45 miles to get here, does it? Because if I'm asking you how long does it take you to get here, you're going to tell me 45 minutes, even though you told me you live 12 miles away. Does that make sense?
Yeah.
So I'm saying you've got 0.0319 meters is your wavelength. But I want to know how much frequency that means. So of course you're going to use a different unit because frequency is measured in hertz, wavelength is measured in meters. Does that make sense?
Yeah.
And you're not the first person to ask me that today. So don't think, oh gosh, it's silly. You are every block someone has asked me that. That's why my analogy got better and better as the days gone on. Okay? Yes, sir.
If you divide 3.10 to the 8, divide that, you get 9.71. How do you get 9.4?
I don't know. Let me check. Maybe mine's just wrong. 9.71. Okay. I may have done mine. I may have 3 second E8 divided by 0.0319. I got 9.4. Oh. So are you using, let me see your calculator. Let me see what you've done. This one? Okay, recording again. So, an FM radio dials are calibrated in frequency. So the radio station Magic 100 broadcasts its FM at a frequency of, so my frequency is 101.1 megahertz. When you tune in your channels on the radio, those frequencies are in megahertz. Okay? So we got to get this to hertz. Hertz is our basic unit. So we put hertz up here, megahertz at the bottom. And let's see, so 1 megahertz is larger, 10 to the 6th, right? So 1.01 times 10 to the 8th hertz is my frequency, correct? Yes? Good. And then, of course, I'm looking for wavelength. My equation is C over V equals lambda. So 3 times 10 to the 8th divided by 1.01 times 10 to the 8th equals 2.97 hertz. Not hertz. I lied. Meters. Meters. Meters.
Oh, yeah.
Yep. Okay? Yep. Does that make sense?
What?
Okay. So, number 28. Let's see. Did you get, let's go over this. So number 28, it says sodium vapor lamps give off a yellow light at a frequency of 5.09, guys. I need you listening. Hertz. What is this signal in nanometers? So I need to know what this is in nanometers. I'll get my answer in meters and I got to make it into nanometers, right? So C over V equals lambda, correct? So 3 times 10 to the 8th over 5.09 times 10 to the 14th. That gives me, well, I had 2.09, that's why I messed up. Divided by 5.09, second E14. So I got 5.89 times 10 to the negative 7th meters. But now I need to get that in the nanometers, don't I? So 5.89 times 10 to the negative 7th meters. Nanometers goes on top, meters on bottom. What's larger, meters or nanometers? Meters. 10 to the 9th. So my answer is 5.89 times 10 to the 2nd meters. Did you guys get that? Yeah. Yes? Yes, that's fine. Or 589, that's fine. But if you really want 2 digits after decimal, okay? I don't know if I turned it back on or not. Did I? Oh, I did. I can never tell. Okay. So then, number 29. 29 talks about AM radio stations. AM radio stations broadcast in kilohertz, where FM broadcast in megahertz. So that's why they kind of sound like they're in tin cans. You can always tell the difference. When you're on an AM station, I can always hear the difference. So, basically, you says you have 830 kilohertz. So I have to get that to hertz first, don't I? So, hertz, kilohertz, That's larger, 10 to the third. So it's 8.30 times 10 to the, was it fifth? Thank you. Fifth hertz. C over V equals lambda. So 3 times 10 to the eighth divided by 8.30 times 10 to the fifth. And that should give me 361.44. Is that right? So what you guys got?
I did 4.5.
4.5. Okay. I don't have the answer down, but I just remember it from other classes. So, and that is in meters. How did we do with that? Good? Now the last one's a little tricky. The last one requires a little thought, but this is stuff we're going to be doing when we do dimensional analysis. It's kind of just a lead into it. So it says some earthquake waves travel at 5 kilometers every second. What is the wavelength? That's my question mark. If these waves of the earth, if the earth tremors are 10 waves per second. So they happen 10 every second. What's my wavelength?
Isn't wavelength V?
Excuse me?
Isn't wavelength V?
No, wavelength is, frequency is V. Wavelength is lambda. So what's my unit for wavelength that I'm going to be looking for? Wavelength unit is what? Meters. So I'm going to get to meters somehow. My end unit has to be meters. Well, the only place meters can come from is my kilometers up here. So I say, okay, let's get kilometers to meters. Kilometers on the bottom, meters on top. Kilometers is larger, 10 to the third. So basically, 5,000 meters per second is the speed of this earthquake wave. Okay? 5,000, sorry, 5,000. So, if I got 5,000 meters for every 1 second, and I know every 1 second there are 10 waves, it's going to go 500 meters. What's on top and what's on bottom always cancel each other out. Okay? So you'll get some critical thinking here. You've got to think it through. Now this is a little challenging one, but I won't give you one of these on the quiz. Not this chapter. Okay? How are we feeling?